Alright, now let's have a look at circles. So, if I have my xy plane and I just draw a generic circle, this one's radius 2 because it's going out to 2 at all points, 2 and minus 2. Okay, there's my generic circle. That looks nice. It's nice, it's different, it's unusual. Okay, and let's say that I've got a generic point on this circle and I'm going to call it point A. And point A has coordinates x, comma, y. Like it's gone across x and we've gone up y. And let's draw a line out from the center, so from the origin to there. And then I can draw myself a nice little right angled triangle. And I'm going to draw that right angled triangle over here. It's not going to look amazing. So this is the length x, this is the length y, and this is the point x, comma, y. And let's say that I wanted the length of the hypotenuse. So this is O and this is A. So I'm going to call this length OA. Now if I wanted to know that length, OA, then I'd just do Pythagoras. OA squared equals x squared plus y squared. But that OA is going out from the center of the circle, isn't it? So that makes it the radius. So the radius squared equals x squared plus y squared. That's literally it. We usually write it as x squared plus y squared equals r squared. But that's literally the equation for a circle that's centered on the origin. So for example, if I had x squared plus y squared equals 9, well, you know that that's 3 squared. So I would know that that was a circle with radius 3, and I would be able to draw it very easily. Pretending I hadn't stuffed this up already. Y, x. Oh yeah, this is going to annoy me. I've got to fix it up. Move it. Yeah. So it's got radius 3, so it's going to go down to minus 3, it's going to go up to positive 3, up to positive 3, down to minus 3, and I'm going to use a big fat pen so my mistakes are less obvious. But hey, I'm on a computer, so this does it for me. And that's what it's going to look like. It has radius 3. So if I have a look at some of the questions you'll be asked to do, the center is literally at the origin, 0, 0. So if I have a look at some of the questions you'll be asked to do, for example, question 1, I'll pull it up here. Question 1 literally asks you to find the radius and the coordinates of each circle, the coordinates of the center of each circle. Now, in this exercise, you can always assume the center is the point 0, 0. In chapter 4, we're going to get onto different transformations of this equation, so you'll see what happens. Let's have a look at this one, because this is the funkiest looking one of all of them. So we've got, for 1C, we've got x squared plus y squared equals 1 on 9. Well, I know that the square root of 1 on 9 is 1/3. So I know this is x squared plus y squared equals 1/3 squared. So it has radius 1 on 3, center 0, 0. What's the next kind of question I've asked you to do for these circle ones? 1, 2, 9. Question 2, oh, so easy, you're just drawing them. Question 9, finding the equation. Ooh, okay, I'm going to do question 9C. Let me grab it. Okay, question 9. Now, with this one, it's really easy to see that the radius is 2. So that's x squared plus y squared equals 2 squared. So it's x squared plus y squared equals 4. This one, the radius is root 5. So it's really easy to see that it's x squared plus y squared equals root 5 squared. So it's x squared plus y squared equals 5. This one, however, it's really hard to see what the radius is going to be. But I know, I can't match it perfectly. I know that x is 3 and y is 4. So if I have x squared plus y squared equals r squared, and the point they've given me is 3, 4, I'm going to sub that in. So 3 squared plus 4 squared equals r squared. 3 squared plus 4 squared, 9 plus 16, 25 equals r squared. Can you tell me what r is yet? R equals 5. This one you're going to do the exact same thing, but you're going to have, and this is x and this is y, you're going to have, so x squared plus y squared equals r squared. So we've got 1 squared plus negative 3 squared equals r squared. Those brackets are important. So 1 plus 9, so 10 equals r squared. So r is root 10. That's it. They're fairly simple, actually. And then question 17. Oh, now if they've decided to be mean, and I'll grab this question and show you, question 17. If they decided to be mean and give you questions with square roots still in them. So let's have a look. Oh, come on, crop. Now, if it's still got a square root in it, that means it's a semicircle. Because if we had if we have y equals negative root 2 take x squared, then we've got negative y equals root 2 take x squared. So negative y squared equals 2 take x squared. Plus x, negative y all squared is the same as y squared. Take the x squared over, we've got x squared plus y squared equals 2. So its radius equals root 2. But if we had have actually sketched this, y equals root 2 take x squared, then we would have sketched, it would have looked a bit like that. Oh, sorry, we've got the negative out the front. So it would have looked a bit like that. So it's literally just half the circle. Oh, no, a better semicircle. It's literally just half the circle. We're only taking the negative half because it's a negative out the front. But I'm not taking the whole circle, I'm only taking the bottom half of it. That's it. Now, it says to also state, It says to also state any points on each curve whose coordinates are both integers. So, that's going to be a really hard one when we've got the square root. So integers. If we've got y equals minus root 2 take x squared, then what we want is for this thing under the square root to be a square number. Number. 2 minus x squared, so we're not going to get 4. Don't forget our square numbers are 1, 4, 9, 16, etc. Well, 2 minus x squared, if we had that coming out as 4, well, we're never going to end up with that coming out as 4 because it's 2 minus x squared is going to be a positive number. The only number we can aim for is 1 under this thing, yeah? So 2 minus x squared is going to come out as 1. which means x squared's got to be 1, which means x has got to be 1, or x equals minus 1. The points on that curve, if x equals 1, y equals negative root 2 take 1 squared, so y is going to be negative 1. And same if x equals minus 1. Y equals negative 2 root 2 take negative 1 squared. It's still going to come out as negative 1. No, why did I chuck a 2 out the front? Meh. Still going to come out as negative 1. So that's those.